more about horizontal asymptotes. As a reminder, what we've mentioned is that horizontal asymptotes describe, oops, describe end behavior and used dashed lines to represent. These are the two things that we've talked about in a previous video. You can kind of see the horizontal asymptote from the previous video up above. And so let's talk a little bit more. There's a lot going on here. Let's kind of dig through it. Just like we did with polynomials, we want to know about end behavior, right? So that's the big question. We want to know about end behavior of an exponential. When we looked at the graph of 2 to the x and 1/2 to the x, we had some similar end behaviors, some things kind of switched up, right? Meaning when you have, if we're talking growth versus decay, end behavior is similar is what this is saying. It's really wordy, so let's kind of slim it down a little bit what they're saying, right? So here was your example with growth. Here was the example with decay, right? And they are using the limit notation, right? So for the growth, this is why it's nice to determine whether you're looking at growth or decay, right? And so we had a horizontal asymptote. We like to draw it using a dashed line. This is just kind of a fact that you're going to need to know about exponentials. But more so, exponentials are not the only functions that exist that have horizontal asymptotes. Many other functions exist also that have horizontal asymptotes. The key definition for a horizontal asymptote, whether it exists, is when the end behavior goes to a number and not positive or negative infinity, we have a horizontal asymptote at that value. So looking back on these two graphs that we drew up above, right, where as x went to positive infinity, our function went to 0, right? So the limit as x goes to infinity of this function is 0. Oops, sorry. That tells that we have a horizontal asymptote at y equal to 0. And it just can be one end. It doesn't have, it can be both ends. It can be one end. This is an example of one, right? So like we see on this one, as x goes to negative infinity, our f of x is going to positive infinity, right? So the limit as x goes to negative infinity of f of x equals infinity, right? This example would say no horizontal asymptote here, right? Because it's going to infinity, whereas the other one is going towards a specific value. One of the easiest ways to determine if a function has a horizontal asymptote is by looking at its graph, right? The key indicators of whether or not a function has a horizontal asymptote, what I do, I really love it in this second one, so I'm going to zoom in, is what you'll notice, right? Since we're focused on the ends, you'll notice this end has a very specific behavior. It almost starts to look, it's drawn in purple, like this horizontal line. Just on this end, right here. And we just kind of extend it. But like graphing calculators won't necessarily tell you there's a horizontal asymptote, right? You just kind of have to figure it out by looking at the image, right? So what I notice is that there's a possible horizontal asymptote here at y equal to -2, right? And I got that value from right here. So let's label this graph. I know this is number 2. We could start with this. Let's label this end. Let's label this end. So end number 1, right? As x goes, we're going to negative infinity over here. And our outputs What do we want to call this function? Let's call this function g of x, since we've been using a lot of f of x's. Let's call this one g of x. My outputs are going up, right, to positive infinity. So the limit as x goes to negative infinity of g of x is positive infinity. No horizontal asymptote there. It's at this second end, right, where as x goes to positive infinity, it looks like my outputs are tending towards -2, right? So the limit as x goes to negative infinity of g, a positive infinity. My apologies, let's fix that. The limit as x goes to positive infinity of g of x is -2, right? So this information will also tell you horizontal asymptote at y equal to negative. Just means one end is going to a value, is all that kind of means, right? And so just kind of being able to visualize it with these graphs. And so let me cut this page in half. Let's label the other side and then we'll be done. Some graphs are a little easier to tell than others, right? It takes a lot of skill and practice and understanding. If this is your first time, it's a little bit harder. Just learning how to like kind of really hone in. Oh, this graph kind of looks like it's not going to cross or it's going towards, right? Because we kind of assume what's happening with the picture is going to keep happening forever and ever, right? And we've got to be able to visualize that in our mind, even though it's not really appropriate for maybe this side of the graph. It's this that we're describing, right? And so what's that y value? +1. You got it, right? So let's label this end number 1 and number 2. So end number 1 as x, my x's are going to the left, so negative infinity. Let's give this function a name. Let's use one that we haven't used yet. Nothing creative, h of x. Right, this function h of x on this end is going towards 1. Right, so the limit as x goes to infinity of this function h of x is 1. Even though the function may never actually equal 1, we're just describing what the end is doing, right? It's kind of stuck by this output. Number 2, as x goes to positive infinity, since we're on the right side, my f of x, oh, no, we called it h of x. See what happens when I change the name? Going up to infinity. No horizontal asymptote here, right? The limit as x goes to infinity of h of x is positive infinity. One final note before we move on about horizontal asymptotes is they can cross. Graphs can cross your horizontal asymptotes. So like just, I guess, final note. Graphs can cross horizontal asymptotes. Let's draw a picture of something with a horizontal asymptote. This is a common function that I saw in some of my upper division work, where we have this function. Let's draw it in blue. Let's say it does like this kind of behavior. Right, and what we notice is at the very, very end of this graph. Yeah, it kind of bounces around. It does this little wave pattern. But at some point, as x went to infinity, my output started to dampen down or started to look a little linear, right? And so this line right here, remember, because horizontal asymptotes are end behavior, your graph can bob and weave all around a horizontal asymptote. It's just this end that we're describing. So let's give this a value. Why not? You choose. Let's choose, I don't know. What do you guys think? 1, 2. We'll go with 1. It's a nice number. At y equal to 1. Right? It just, all it's doing is describing what's happening here. So graphs can cross them, bob and weave. It's just all about and behavior.